Alright, I'll try it about there. Hello and welcome to Bug Free Productions. Today we're going to do something a little bit different. Instead of doing one topic for the whole thing, we're again splitting it. But yeah, welcome to Bug Free Productions. You can find us on Twitch or YouTube. I'll have a couple developers at some point during this next couple months, hopefully. Next 2 months. After that, things will probably die back down again for masters, and we'll see here. Flip over to the ordered. So yeah, remember to check out twitch.tv at Jim at BFP or the YouTube at Bug3 Productions. So channel's also taking a little bit different direction than just being like a portfolio piece. It's mostly just going to be for showing a couple things, making a couple videos for different kinds of content I need to make for like based on classes and other things. And then we'll also have so it'll be like part instruction, part demo reel, and then during the streams, everyone's welcome to ask questions or anything else that they might have. Not everything's a question. Often things people want to talk about are a concern. But or even just ideas. So I'm gonna start this off with, let's go ahead and get this open here. That's the new playlist. So let's go ahead and do some listing quick. So today we're going to go over the observer pattern. Observer pattern. And then after the observer pattern, we're going to go and continue on our bootstring spawner. And as always, I have prepared an absolute zero amount. The other thing is these streams will start being one coding, one art, so that I can have code finished that I'll overview on these ones, at least for part of it, before moving on to programming, because programming, well, trying to do this is a little, you can only do it for so long. I can only do it for about, apparently an hour is what we've pretty much discovered. After an hour, my brain just starts melting when trying to run all of this. So we'll stay with this next thing and see if this helps out at all. So it won't be a pattern every time. Sometimes it might just be an idea for optimization, or something that I'm reading. Like right now I'm reading the new game design patterns book that I've been reading. I say new, but it's from 2014. Patterns book. Yeah. And if you're watching, keep in mind I'm a designer and a developer, so I've done graphic design and videography and photography and all that stuff on top of the game development in Unity, C# and also application development in Rust. I know Python don't end up liking it too much, so I'm pivoting more towards Rust. I'm gonna see, because that has a lot of C++ utility, where Python doesn't. So I'm looking to see if I can leverage some of that and make something a little bit cooler. if you were watching the last one or you peeked in on the last stream, you probably notice two new things we added to the project list. They are codename Beautiful and codename Great Personality. Um, yeah, Beautiful is the application, the Rust-based virtual assistant application that functions basically locally like Siri. And then Great Personality is the extension that I might be building soon here, where it is going to look at your drive, it is going to pull that, parse it, so that you don't have to keep it locally, but you could still have an agent that you could chat with to bring that sort of stuff up. And once again, local security, privacy focused application on that end, even though technically it's going out to somewhere that's maybe not private and getting that information from, like your Google Drive or something like that. But essentially that's what the idea for that one is, and that's the code name I've kind of given it just because I needed something to talk about it with. And the other AI type application was already named Beautiful. So we're just going to continue with that naming convention. And we're going to see where it goes. But today we are in Bike Race. Which is an arcade racing game where you can go 360 rotation with your bike while racing. I kind of wanted to get like some Sonic elements in there and some Sonic Riders elements, and as well as some like other arcadey type stuff to run really nice. So we're going to be focusing on that kinda. And today is mostly focused on the boost rings. After we go over the observer pattern, I'll show you how that works the way I do it anyways. And there's a couple different ways. Some people might prefer to just use Unity events in general instead of using like this whole concoction that I set up where you can plug into the Unity event system. But I'm kind of not sold on staying on the Unity platform just yet, at least for the near upcoming projects after Bike Race. And VR Classroom doesn't really utilize any of that. So I just want to also keep that separate because then it can stay in the library and move between different projects. So what we're going to do is we're going to actually just jump away from this thing. Or not away from the book. We're going to jump away from Unity events and some of the Unity systems in general and try and keep it somewhat contained so that translating it later is a huge hassle. So I'm going to go ahead and jump on over into Unity. So this will probably take a little while because I haven't opened it yet. So we're going to check some factories. So I'm going to also go ahead and start some clips as we get stuff pulled up. But factory item is what I need. And we'll see how many things I need to pull up. Just when I open. For some reason, Codium doesn't seem to be opening the SLN to the point where it was in the last sessions usually, which is kind of weird. So subscribing factory, subscribing factory item. Okay, so I'm gonna open and open. So it's also not a perfect implementation of an observer. And part of that is because I'm kind of nestling some adaption in my old code. And we're going to go ahead and switch scenes to full screen. Okay. So, placeable objects, object factory. So placeable object is something that was from the VR project, not necessarily in use here just because of the dependencies that ended up being needed, and I didn't want to transfer those just yet. Then we have subscribing factory SEO. Also comes up that even though like I want to merge the VR classroom and the regular library, like some of them in from out that, it is worth notice and mentioning that it's not going to be smooth because it's going to destroy all my SEOs basically, which is not great. So we have subscribing factory item and we have subscribing factory. Those are both open. Then we just need the generic factory. And we need the interfaces. So we could probably find those in Observer. And inside Observer, we have the iSubscriber and the iSubscriber notification, and the iSubscription. Now I'm just going to open these guys. All right, gonna chug some water. All right, now with all their scripts open, I'm gonna go ahead and start this one. So let's go ahead and start the recording. All right, so hello and welcome to Bug-Free Productions. Today we're looking at the observer pattern. Quickly before we move on to some development here. So the observer pattern is just creating a way for one object to observe another. And we're going to use a delegate in this type of pattern, at least for today's usage. So the one thing about Unity is that you can only inherit, or not just Unity, but in C# in general, you can only inherit from one class at a time. So if I'm inheriting model behavior so that I can use Unity type stuff, I can't necessarily inherit other things from, like I can't inherit from a second class. So that's where your interfaces are pretty useful, is because I can still build out like behavior without necessarily needing to use a class for it. And so here I have the subscriber or the observer. So a subscriber observes a subscription, and an iSubscription can be subscribed to, it can be unsubscribed from, and it can notify the users. And then a subscriber can be notified, it can subscribe, and it can unsubscribe. The reason these don't have those in there is because I'm kind of assuming that they know where they're supposed to subscribe to. Not necessarily always true, which is why there might be one method that I add in here later that is just subscribe with a subscription as a parameter. And notify takes in a iSubscriber notification. So what is an iSubscriber notification? This is basically just something I created. It's kind of empty at the moment, but the idea was I can still inherit or I can implement an interface into a struct, and the struct is what I actually want to use, but I kind of just needed a common base type, so this is kind of just a do nothing interface that is kind of just used as a common type. I might use it for something eventually, but this is the way it is now. So we have in iSubscriber that will eventually be passed into it as a subscription message when notified. So let's look at a quick implementation of this. Over there, I have the iSubscribing factory item, which implements iSubscriber. So what does the subscriber actually do when we define the methods? In this case, I don't really use the subscribe because I can't statically get what it needs to subscribe through or subscribe to. Another shot of water. Instead, what I need to do is I need to get that live. So I made a different method, which is one I might move into the actual interface. Public subscribe iSubscription. So passing in a subscription from the factory that creates this item, it will know who to subscribe to. So this guy will get called by the factory, and then he will subscribe to the subscription that's passed in, and it will pass itself as reference so that the subscription can decide what to do with it. There's a couple different ways of handling how this works, and we'll look at that when we move over to the subscription. And then I add the subscription to this object. So this is a little bit different. I can't really define a property inside a interface, at least not the way I've been doing it. So subscriptions.add, I add a subscription to this object, and then when it needs to unsubscribe, so I'm assuming like on destroy type stuff, whenever it's destroyed or leaves the Unity field, we will be unsubscribing, where we just talk to all of our subscriptions in the list and we unsubscribe from it, and then we remove the subscription from the list. Pretty simple, straightforward code here so far. The one where it's not fully laid out in the interface is the subscribing factory SEO. Or not this. Let's flip back to Unity. The trail, the data, we'll go back to older again. The trails, the multiple orientation trail system. So where we have an iSubscription here, the implementation of this subscription, the subscription class that implements this, can take pretty much any action it wants as long as it implements the add point render trail. It's very far down. Subscribe, iSubscriber, and on notify. Notify and the unsubscribe methods. So as long as these are implemented in some way, the implementation is happy for the most part. And the way I do this is, instead of storing all the objects in a list, I went for the delegate approach, where we add all of the notify methods to a single delegate. That's why that underlying interface type of the subscriber notification is so important, because then all subscribers can just have all subscriptions can just pass a value for that subscription notification through, and they're not necessarily bogged down with some of the other things of being like a specific struct or anything else. It keeps the system very flexible. So onNotify, then we have onNotify invoke, and it just invokes the onNotify delegate with subscriber notification that it pulls. Then unsubscribe is just removing the subscriber from the onNotify, so removing their notify method from the onNotify delegate. You could also use the same thing and set it up as like a list of subscribers and manage the list and call all the notify methods on that on the instances in that list. But this is a little bit more performant, and we don't have to have that list. There's a big collection of memory, so we just kind of avoid that. This is the one that's preferred by a lot of people, is just using a delegate. So our delegate is just protected action subscriber notification on notify. So this is just a quick way to build a delegate. Otherwise you'd have to there'd be 2 lines instead of this one. And here's our subscription notification. So this would actually be, once I start making stuff here, I would actually create a specific not interface. I would use the interface to create a very specific struct that would store my values, and I could just pass them through to the different observers. And subscribing factory was just an edit, so if you popped in on the last stream, you would have seen me futz around and tear my hair out with a set on methods to where this factory create method wasn't really working. And the reason it wasn't working is I accidentally auto-completed to protected, or absent-mindedly typed in protected instead of public. So instead of creating a public method that I could call from somewhere else, it is a protected method, and it was looking for the first public method it could find, which was in the base class, which is why it was taking me to the base class on error, and I had no idea where the actual problem was, and it was just a typo. So that's pretty much the factory pattern. At this point, I think we're gonna end this clip, and I'm gonna move into the bike race. So now that we have that working, let's go ahead and hit play, and we'll do a little run. We'll see how this goes. So you'll notice the offset trail running, you'll notice the multiple trail system running. So nothing's actually been changed too much. Actually, after the last stream, I was trying to do some setup on the boostring, and I got some of the prefab set up, but I don't think I set up the trailing placer. So we're going to look at that for a little bit. It's like what our console problem is. Oh, that's just a stop problem. So because some of the objects are in scene at start and don't ever get spawned in and get the extra reference to like a pool, technically the error when they get dumped. So while it needs to get cleaned up before game launch, it's not important right now because it only fails on close application. So if we want to look at that stuff, we can go prefabs, and in the prefabs we have bootstrings folder and boostring, which is right now a prism. So we're going to look at cube. So cube is just the mesh filter and mesh renderer and box collider, basically the collision and visual for the object, while boostring is the overarching object. This is a scriptable factory item of boostring. So we see that we have this here. And then I'd probably also create like an actual boostring script And I do that likely from the assets folder from scripts, because I'm not certain that I would want it in the library. Is string. And then we do C# scripting. And it's going to need to be amount of behavior because it's going to need to go on the do string object. Do string. And double click open. So we're going to do quick courtesy comments. There are multiple contributors to possibly the library. We haven't settled on that yet. But there are multiple contributors to the bike race application. And we're going to set it /u/226. And sure, we can leave the blue bug on. Okay. So, time for serious development. First thing we always do, I'm still not used to this new interface. I was barely used to VS Code. I started with Community. I started with Visual Studio Community, moved to Visual Studio Code. Now I'm on Codium, and while it's not entirely different than Code, it does have some like weird snapping compared to Code. But at the same time, my continue application actually works on here, so there's that. Created by, not created by the date. No, it's not right. Tab, tab, :tab. All right. And this is going to go in my namespace, and this is boostring. So actually namespace of still bug-free productions, but this is going to be .arcade racer. Because this is specifically for the arcade racing game, not necessarily the tool setup. And with that, I'm going to open a bracket and close bracket. I'm going to do my boring setup here where I create regions. This is going to be bars. Then we're going to have another end region. There's going to be bars in here. Then we can might as well do the methods too. Just copy paste this. Not certain I'll have not certain I'll have any access routes yet, so not create a region for those just yet. See how far we get. So I think that I need to look at the CMD request. So using bugfreeproductions.tools, we are going to inherit from CMD. So we have client request and a service. So a service sits on a object such as a player and would perform an action based on the client calling And then we have the request, which actually runs. So let's take a look at the client and just confirm that that's what I'm looking for. So command request equals get component cmd request. So it looks for the request. That's an odd way to write that, which is weird because I wrote that. If cmd request not equal null, then cmd request dot game object. Okay, cmd client looks for the request. Okay, looks on an object for a request. And the reason this is written as cmd client is because there's actually two separate ones now that I'm remembering. This is to be inherited by collision and trigger client. So I'm going to go back. And is it suffix? It's a prefix. So collision cmd client. So collision command client. This is actually more of a service pattern, but we're not fixing everything right now. That's a mass rename operation we can do later. Also not certain if that qualifies as a service pattern either, but we're going to continue. So we have a region, collision command requirement. Let's look at this guy. So it should be very similar. You'll notice that I even commented this out just so that I remember what the basic function is. And then on collision, we have a protected virtual void on collision defined. So this guy is going to be overridable or overwritable. And then it returns void and has on collision, a type of collision. And then we request from the collision that occurs the game object. So just what object we actually collided with. And then we run request on that game object, which is the whole thing we already covered of looking through the different things, looking for requests to call. So that's all good. And then the way a request works is it passes in this object, not looking for a different object. So this object passes itself directly to the object when we make a request, meaning that we don't need to specify what type of object we're looking for because it's all handled down the chain of responsibility. So let's use the back arrow to just shift back a little bit. So command ring. So actually we're already seeing, I think, at least it looks to me, like this should probably be in tools. Because essentially what this is adding acceleration. So whenever a player hits a boost ring, it'll add acceleration. But by adding acceleration, we don't necessarily need to make it a boost ring only object. So we can change this to be like we can make another one that is a collision velocity increase or something. We'll keep boost ring as the name right now, and then we'll rename it after. Just because I still am thinking of names and I don't really like velocity plus. So this will be We'll just call it add force, something of trigger eventually. And if we're doing add force, then we can do in the methods, we want to override our on. I did COL and I want trigger. Because our boost string is going to be a trigger. And then same here, so I want on trigger enter. And there really is no difference between the trigger and collision client I set up. It is just I'm just gonna go here and copy it because I can't. Maybe I can't. Here, grab this. Yeah, there we go. It's just the difference between a command, like a collider being marked trigger or as a collider. So depending on that, I'd either put a on trigger command or an on collision command, just because we need the specific check for are we triggering or are we colliding. So protected override void on trigger, collision enter. We have the request firing. So actually this would probably be perfectly fine to leave as well for right now. And this is if we're finding an RB. Yeah. So then if we have an RB attached to the other object, then it's running the request. So what we actually want, probably didn't even need to do it here just yet. It probably would have been better to start with the service first. So we'll go ahead and create a acceleration boost service. Create C# script. And we want a mono behavior because it's also going to go on a object, although a player object. So let's say acceleration boost, because I'm so creative with names. It's actually very funny. If I'm doing body copy, I can like actually think of names, and if I'm programming, I can think of 0 names. It's kind of weird how that works. So created by, not space, tab, shift, tab. So we have this, and then we have created. And what about created? It was created today. 2022, 2026. Yeah, acceleration, AC. I'm feeling that's spelled correctly now? And if you're ever wondering about what these blue things on here are made from, these are Street Side Software's code spell checker. And what was the other one? Code spell checker and error lens is what writes them online. So instead of having them out here, it just writes them right in line, which is very useful, especially if you are like me and don't want to look between two different windows. Even just windows can be an awful lot to deal with at the moment. So acceleration boost, we're going to copy that, Control save, close that, and then we're going to flip over back to Unity and rename it because it's a spelling error, not a naming error. So we're going to go F2, Control B, Enter. And it's worth noting that you don't necessarily have to follow along in typing, although probably would help on some of the simpler stuff. But especially since you don't have all the namespaces I have, because I am just working in my. Why did I do that? I'm just working in my library, but you can look at the GitHub repository, look for Isaac Busted, and you'll find him all lowercase letters. And it'll be the Bug-Free Productions library. And it's public, so you can download it and use it on your Unity game packages, all that stuff. There's currently no license on it, but it'll probably be something like MIT or open source. Not necessarily looking to make money on that one, just trying to get my name out there, and then also give me a unified library to pull all the crap from and not necessarily have to keep writing new code for everything, at least the basic crap. So we got public classes, acceleration, boost, and this is going to be a CMD. And it's not going to be a client, it's not going to be a request, it's actually going to be a service. So a service is run on request by a client. So we want a CMD service to run and be found by a request. So let's look at service again. Service basically has the request function or method. So it has the request method, and it's going to be debug. These were line testings, I think. So it's going to call a service on a game object. So as we saw with the command request, the client, rather, as we saw with the command client passes to the command request, which passes to the service, which we actually service the game object that's passed. And in a service is where we'll define how things differ. So once we get to this point of making the service, we'll actually override this method. So let's go ahead and override it. Let's go ahead and follow. You'll notice that the class uses comments to separate instead of regions, and that was a learn as you go type thing. So I've been building this for about just slightly over a year now. End region, bars, region, methods, end region, methods. And then we're going to, in methods, paste, and override. So then service. So the idea is this service executes quickly on a local object. So this is going to be on our racer body. So I think I can just use get component. Get component. And it should be rigged body. Alternatively, I could serialize it or get it on start. Let's actually check that, because that might be a better solution. So if you flip back to our main scene in the game, in the player node, where's my rigged body at? Rigged body is here. Is my racer CMD request is here. Okay, solid. So then it will be on the same layer as the rigged body, so we can get component. But instead of getting component every time on a service call, we might want to have a reference up here. This would be a rigged body, RB. There. Set that equal to null, just to be explicit. Rigged body here. So now we can use RB dot. It's going to be add force. And the parameters of, let's add another serialized field. And we're actually not going to have a direction from the racer, right? If we go through a boost string, the boost string determines the direction we get acceleration. Or we just accelerate straight forward. So one of the two ways. So maybe we open that up and think about that for a minute. A. Accelerate straight. B. Indirection. And even with this branching, I'm kind of seeing, at least to me, this still doesn't look like it belongs in the service part. It looks like it belongs to me in the boost part, the acceleration boost. So acceleration boost should probably be the request or the client, and the acceleration boost class should be named something different. The naming on this is very bad. Let's do that. Well, let's actually differentiate that by just doing CMD, but putting this as a suffix for now. And we'll do the same thing for the other one. Acceleration boost. Then its service different. Service doesn't need different ones because it didn't need a trigger and command one, or collision one. So it just has the one set of stuff to do. So I think as long as I do this, it should be fine. And we can add the force. Add force, and we can use the parameters of, I'm going to assume AGO. Dot get component, and we're going to need to wrap this a little bit. So this is going to be the acceleration trigger command client. We're going to have to set that equal to, actually we can use something new, because I have a feeling I'd probably also create a collision client as well, eventually. So let's go ahead and run double logic on that. So this is going to be trig CMD client. And then a trig CMD, or a trig client. My trig client is going to equal to I'm trying to think of the syntax to do this new cool thing. If, it's an if statement, if ACC acceleration boost trig command client AGO dot get component and if this get component is acceleration client. There we go, the acceleration client. Then I have a feeling I messed up the definition of it a little bit. Maybe it doesn't need this. There it is. Perfect. Now we can use that variable I just made inside the if statement, and it'll be an acceleration client, and we're going to get the dot acceleration and we have to decide, so we want it to either boost them straight ahead in the direction they're already moving, or we want it to push them in a different direction. Which is a little more difficult on this class. So let's just assume we're adding a straight up vector, pushing them in a direction determined by the boost for right now. So let's go. Boost direction. As long as it's spelled right, that's all I care about right now. And this can actually be an accessor, so we don't need to use the parentheses. And then I'll go make this. And we're actually going to ignore CMD client. We can let the client function exactly as normal on trigger, but we need an accessor. So actually we didn't even end up using methods, we just ended up using accessors. So end region. Accessors. Then we can paste that. And this is going to be a public virtual and this is going to return a vector3. Vector3 boost direction bracket get nope. Do not like my brackets on the same line if I have plenty of lines to do it in. So get is going to return and then important to keep in mind that this is a mono behavior still. So I'm going to add a variable. I control C when I should have V'd. We're going to do lowercase boost direction. That's going to be a type of vector3 that's going to be protected because I want it to be passed if I inherit later. And I need to assign it a value vector3 dot 0, which just means it's a vector3 with 0 for x, y, and z. Which this comes exactly from the vector3 struct. Which 0 must be a method. Yeah, it's a get method. Okay. So this should all be good. Vector3 boost direction, return null. And then we're going to return boost direction. Then I'm going to back until I get to my other class. My other class is still not there yet. Maybe I should just look for, no, this is the right one now, right? Rigid body, yep. So boost direction, so we're adding the boost direction. So boosting in a straight line. And we are going to use a different kind of force mode. So I'm going to shift the force mode from acceleration client. I'm going to shift the force mode from the default, which is force, to force for explicit sake. So overall, pretty straightforward. If anyone ever wants me to go over the command and service path type mess I've made, I always can. Gonna need some water. And then we'll move into making the little check marks and the allowing it to add to the forward position or the direct position. Ooh. I remember teaching Unity in class, that was fun. Did everything through line renderers and physics. Okay. That's enough water, probably. So let's go ahead and run into the next thing. So I mentioned earlier that it was going to be kind of a pain to flip back and forth between how I apply the force. So let's not focus on how to apply the force right now. Let's focus on how to access the force and then figure out how to apply it. I'm thinking that I'm going to need some sort of way. Ooh, orientation data. Yeah, that's a cool, interesting idea. What if I was passed an orientation data or could request an orientation data from somebody else, from some reference? We'll look at that later. That's a good idea. That's interesting. We go forward because you can't. So there we go. Acceleration CMD client. And essentially in here, I want to add a Boolean or some sort of basically a Boolean. I want to make sure it's serialized. Serialized field. And it's going to be protected just in case I need to inherit it. And this protected variable is going to be a Boolean. This Boolean is going to represent if we are boost in direction. MDIR. Boost in direction. And I think I'll actually set that equal to true. Usually I would default to false. Actually, maybe in direction is a little too. Maybe we need like a in service direction or in. Maybe we just leave it false and say, maybe we leave a comment, because I can't think of a good. And if anybody ever has like naming ideas or something, they can always throw them in chat. This is not what I'm focusing on when I'm writing code. In boost direction, let's call in boost direction represents if the, I can't think of a better word, so player, because technically this is going to apply to a lot of things, maybe object. If the boost is applied to object, on its orientation. O-R-I. I think it's more that I can't read that word than that I can't spell it. Let's test that. Yeah, there we go. I couldn't read what I had written, so just gotta retype the whole word. Accessor. Acceleration boost. Okay, so if this is false, then we just apply a boost in the normal direction like we have here. We can. If ACC acceleration client dot, and we notice we need access to it, so we'll add an accessor here as well. It'll be boost direction. And I'm doing it this way simply because I don't want anybody else writing to it. This is property of the inspector and us only. So we do. I have boost direction already, so I don't need a new one yet. Oh, it's the var I'm looking at though. The var is what I need. I need this bool. BBLIC. Public virtual bool. That made me too tired. Control C. Control V. That's going to be enter, bracket, enter, get, enter, enter, bracket, enter, return. And I'm returning boost direction, make this capital for uniqueness, and the line of execution. And this is going to be boost in direction. Yeah, I don't think that reads well. I'm going to go back and change the other one to be, or I'm going to change it to be true. Based on boost orientation. Booster orientation. So interesting about that. So let's go ahead and just booster orientation. What would I want to do with that? That gives me an idea that the booster should be the client, and maybe we could shorten it to acceleration boost and booster. It's a very low unique characters to the different classes, which could lead to me mistyping it a lot. So we're not going to do that. Boost direction, boost indirection. Only reason in is okay is because there's 3 words, so it changes the shape more than 1 letter does. What would be good there? We're at 113, so we got a little bit of time. Let's go ahead and finish up this if statement. Technically that one would work fine, but so if the boost indirection is true, add force, and then else there we go. This should probably just be serialized for right now because I'm not at all sure how that works. So I could serialize a transform. But what I would actually want it to do is like, I probably want somewhere I can have like orientation data stored eventually. Protected, and then this is going to be the transform will work. Transform. TF. And in fact, it's not going to work once the body replacement starts running, so. Okay. We'll have to replace this later anyway. No. So right away I'm going to add a if transform equal null because there's no way I'm getting the component on the base racer because that's definitely not going to be at the right spot. So if TF not equal null, so if the TF is not equal null, then what do we do? Then we take the transform That's stupid. So we have we take the quaternion multiplied by the vector, by the world space vector, we have direction. Then we multiply by x. So I'm gonna have a vector 3, which is world space vector. set equal to transform dot rotation multiplied by the vector 3 dot forward then what was the other thing? That concerns the vector direction multiplied by the x value or y value. Better. Let's world space vector times equal. That's multiplication equal to the transform, equal to the rigid body. No. The acceleration boost dot magnitude. There it is. Yes. Then we add force. Whoops. That's going to be world space vector. Is the object by the world space the ECT. Who's the object by the world space vector oriented with body transform. Boom. And we'll go through an explanation of this again quick. And we'll do some comments so that I and other people remember what the heck this was supposed to be. So the service, basically we are overriding service to apply a service. I mean, we might rewrite this several times just so that it reads decent. Or get all the R's and override. override a service to boost a body and an intended direction. So by boosting it in an intended direction, we have if game object this one. So if we find and then I'll just double click copy. In the request, perform colon Q hit W and start Q request perform this acceleration allow boost based on, and this is our boost directions. That would be our boost strings direction. And actually, this might even be a bit not quite what I want. Because why are we entering a vector 3 on boost orientation? We'll finish this line up. Orientation. Why are we even using the vector 3? So let's look at that. Why do we need to record this? We don't really. Because if we think about it, that vector 3 getting passed in is going to be in world space. So we're putting down a boost string, then we have to manually figure out where that point would be that it's boosting to, which would be really just counterproductive. Transform dot rotation dot Euler angles is going to give us rotation based out of our. Well, that's still not quite right. Rotation. I'm overthinking it. It's just transform.forward. Transform.forward, the forward in world space, in relation to world space of our character facing. Okay, so then acceleration boost. The boost direction is still great, but what we do need in addition to this is to have a serialized boost value. Serialized fields. Float boost value. That's going to be equal to, let's say, 1f. by default. Let's actually go like noticeable. Let's go like 50F. So that's a float value of 50, which should be enough to move most objects a visible amount. And then let's go back to acceleration boost. And then back to boost ring because we don't have an accessor for this yet. And the accessor is going to be public. And I want to just copy, so I can't type. You guys want to make it virtual. And it's going to be float. And it's going to be named that with a capital E. It's going to get really dark. I'm going to have to turn on another light here soon. And enter. And then it didn't take the capital B that I typed. How dare it? Return boost value line end. So why does this not? Must have at least one accessor. What's... Oh right, I forgot to get keyword. God dang it. Here we go. Okay, so we return the boost value. Then we can go to acceleration and do the boost value. Multiply by boost value. Boost. Did I name it projected again? No. Just copy it. Ah, that's the problem. I don't have the using. Show E. There we go. So now it's moving in the boost direction, yes, and by the boost value, yes. Transform forward is already normalized, so I don't need to normalize it before I multiply it by the boost value. Then there's the world vector, transform rotation. So this also is a normalized value, so we don't need to normalize it before we run. The boost direction magnitude, world space vector oriented with body transform. So world space vector is now by that. Instead of by magnitude, I'm going to go ahead and do boost. I guess I could have named it boost magnitude instead of boost value. Oh well. So there's a boost string. Before I even start testing that, I'm actually going to go and do a check on the math of this. So I'm going to go back to here. And I think I just called it orientation data. And all orientation data is a struct. I chose to use a struct for this, specifically to, here's the enum, but the data down here is a struct. The reason I did this was to hold the position and rotation information, because nothing outside of a game object exists to do that, and this will help me do that sort of stuff. And the math I need to check is down here. We have direction equals rotation data times vector 3 right. rotation data is a quaternion. So a quaternion times the direction we want to look is, yeah, the rotation the direction we're facing multiplied by the forward is going to give us the direction we want to add the force. And my voice is starting to go, so I'll probably, now that I've double checked that math, I might even actually just sign off here. At 1:30, that's a lot of speaking. Okay. Little water. It's 1:30, or been going for an hour 30 minutes, so we're probably gonna sign off now at this point. Gonna go ahead and make sure that this is right. Vector 3 dot forward. Yep. So I want to go forward by my rotation. And this math all looks good. So probably I'll do some testing and fixing and see what happens. I'll try and post that clip I took of the bug-free productions and on the observer pattern, and we'll see you later. As always, you can find me on twitch.tv at jib@bfp, or you can find me on YouTube at bug-free productions, and that video will be up right away on the new design pattern. You can check out my last pod up there as well at this point and see the progress on the VR classroom, I believe. Yeah, that's what's up there. We'll be running some new stuff here soon. Hopefully I can get some programmers and stuff to come on with me. And we have 2 new projects, 2 new AI, ML, local model running applications, beautiful and great personality, a database and assistant versus a voice-to-command assistant. And then we have bike race, and we'll continue development on VR classroom. And I'll probably bounce between the two as I have cool ideas and development progress to share with you guys. With that, we're going to go ahead and delete that. With that, the boost system should be up and running, ready to be tested, and I'll test that for next time. As always, have a bug-free day, and we'll see you later.